Okay, here we go. We're going to solder on the XT60 and the capacitor. I got pictures already up to show you what the process of that is. Just a little tedious. Do this in 3 seconds for a video is not worth the effort, but I'm going to try to show you soldering an XT60 to the PDB on video, and hopefully I can get it right the first time. Again, tend your tips away from everything. Get your big blob on there so it passes the heat better. I got mine set up on 5 right now, my iron. If I need to, we'll jack it up a little bit more, but for now, let's see how far we get on 5. Waiting for it to heat through the wire and pass down into the pad there, just like we did with the ESC wires. No pressure, just trying to hold it still, and while your fingers are cooking is a hard part here. And as you see, that didn't work, so I've got a big blob of extra solder here. So what I'm going to do is heat that back up, tap it on the edge of my magnifying ring there, and clean that off so it's not one big blob, and we'll add a little more heat and try again. Now, see how I took a lot of that blob off, and you can see a lot of exposed wires. That's actually a good thing, because we know we wicked the solder through that wire, so we know the heat's going to transfer. Any extra we're going to add here will transfer that heat even better. So I'm going to crank my iron up just a little bit more. Try this again. Now, one of the problems I'm having with big stuff like this is I've only got the one size tip. This tip is actually too small, but we make do with what we've got. So here we go again. Hopefully this cap don't explode in my fingers. Try to get down in there and help it wick to that pad quicker. Once you get one tacked, it's easier to flow some solder in there to get it all to melt all happy. Okay, so that's looks like that's going to stay for a minute. So be able to do the positive and then go back to the negative. This way I can feed some solder into it and make it a little better. Again, our big ball. There we go, that one just wicked in. Let that cool before I move it. And we'll go back and fill in the other one. And then I'll try to get some macro shots in tight to show you what this looks like. And we're going to tin our tip, get our ball on there. Stay on there. Again, this is very, very hard when your hands are spastic as mine are. A little bit of help. Looks like the one side whipped in nice, so we can just fill in on this side here with a little bit of help. It's hard to do. Show you guys on camera too. Sorry for the sniffles. It's a little wintry out here now. This one's being stubborn. Try not to just blob up a big old cold ball here, but come on, there we go. Now it's liquefied. Alright, ain't the prettiest thing, but I know it's a good joint because I watched it wick in and melt down. So, let that cool. Oh. Another thing, if you notice, I've got the opposite XT60 plugged in here so it doesn't warp those and you'll never get your plugs in and out. So, alright, I'm going to shut this off, get some close-up shots, show you how ugly that looks, but it ain't going nowhere. Okay, now that this is cooled, we're going to test this out and make sure we have no shorts and any issues like that. So, set your multimeter on continuity check. You should get the beeps. First place you want to go is power to power. You know, positive and negative over here. Got no beeps. I want to go negative to positive here, no beeps. Negative to negative, and I should get a beep. Looks good to me. Okay, same thing with the positive. Positive to positive, beep. Positive, negative. Okay, and then while I'm on the positive, I'm going to check every terminal here. Make sure I got nothing. Same thing on this side. Now if you notice the meter showing readings when I'm doing this, it's because the continuity check is also a diode tester and you're actually pushing current through this. So basically we're sending a small signal to each of these pads. So that's okay. We'll get away from all the technical stuff, but that's cool to see the numbers as long as it doesn't beep for a direct short. Okay, now I'm going to go from the positive out here to the VCC on the connector that feeds the flight controller. VCC is good. Ground, nothing. I'm going to change up again, and we're going to go back through again. Check each of these leads here. Make sure nobody's buzzing or beeping or unhappy. That all looks good. I'm going to check ground up here. We're good. And VCC, nothing. So that tells me we're more than likely okay to put a battery on this. But again, we're going to go through this step by step and put a smoke stopper on it and everything before we put full battery power to it. Right now I'm going to plug up the flight controller and do checks again, make sure there's no shorts between here and the flight controller, and we'll go from there. Okay, here we go again. I'm going to do the same checks we did on the ESC as we do the flight controller. Now, one thing I forgot to mention was I found the only flaw I can, well, what I call a flaw in the frame is these screws here and these big nuts right where your camera, this may work for camera mounting, but if it's on one of these mounting plates, the camera has a chance, if it moves, to come down and smack those and break off the bottom of the PC board of the camera. So you have to technically put these in upside down. Same thing on the back here, where this is, that puts the nuts up underneath your wires. So it's going to be constant pressure on there, and it's also going to put vibration into your stack here. So bolts are going to have to go upside down, and then this creates another flaw where your battery pad may not be thick enough to protect your batteries from these the nuts when they're down on the bottom. Now I'm going to use Nomogel on here, which is thicker, but it still may not be enough to protect those over time where your battery's on and off. It may wear through, and again, depending on the size of your batteries, it may not, if you're only running 1000 milliamp 6S, it's not going to cover the whole bottom plate. So again, 6 of one, half dozen the other. That's just one of the things that I noticed that could be addressed if they used those capture nuts in these 4 spots on the frame. That would have been perfect. Maybe something to think about for the next revision or next time they got to cut carbon. But anyway, on to our continuity checks. Again, make sure the meter works. I'm going to go negative, and main things you're going to want to check is all your pads here, but anything that has voltage to it, negative to negative, positive, and so on and so on. So that should be the negative for the receiver. That should be the positive, and that should be signal. Over here, it should be negative for the VTX, positive for the VTX, signal for the VTX. Everything's good. Over here, negative for the camera, positive for the camera, signal for the camera, control for the camera. So that tells me that those paths are good. Now we're going to go do the same thing with the positives. So if one's good, usually your other's good, so it's kind of redundant, but always good to check. Positive, negative, nothing. Positive to positive. See? That could be a problem there. And signal. Positive, negative. Oh, duh. It's got to go through the circuit for the regulators. So there won't be any path until those switching regulators are open. Now they'll let you know that the switching regulators on this are respectable. So, all's good. Just have to remember my electronics classes. Alright, so next step for me would be to pull this out, throw on my smoke stopper, and power it up with a battery. See if we get any indication that it's not happy. So, that will be the next part for this third video of this series. Okay, welcome back. Here we go. Now, some of you are going to wonder why I've got this out the back like that, and you're thinking maybe it'll hit the props and stuff in a crash, but here's the thing. There's your clearance. If your prop bends, it's never going to hit that. With your battery on, the battery is facing forward, but your leads in the back. So usually in a crash, you're going to tumble forward. Okay? So if you throw your battery, normally it's going to pop out the back, and that's going to allow that to eject straight out and not get tangled into props. Okay? So you're not going to have any exploding batteries. That is why I did that way. Not to mention trying to mount that cap in there would have to be either where it is now or straight up, and that's just, there's no way to support that other than hot glue, and that's just not going to cut it for electronic parts. Okay, this is my smoke stopper. I've got your male end here, a male end here, so you can do it this way, you can do it this way, but the way I did it this way because here's the light bulb for it, but this also doubles as a way to drain down your bad batteries if you have dead batteries. I don't know if anybody has watched my video tutorial on how to get rid of lipos, but that's all part of it. So that will plug into there and basically complete this circuit. So power will go through that bulb. Let me get it over here. Completes the circuit, so it goes through the bulb, and it's a way to break the chain if there's a problem. You can pull the battery out if there's a problem, or you can pull it straight out of the connector here. I like doing it this way. That way I can set the battery on the table, plug that in, and if I have to, go here to disconnect the circuit. Now, what we're going to see is when this powers up, that bulb's going to flash as it draws current, booting everything up, especially that ESC. But what we're looking for is it to stay lit really bright. That tells me there's direct short. Okay. So here's what I do when I do my checks. This will run up to 6S supposedly, but what I'm doing here is I'm using a 4S battery to test it on storage charge. That way you're not getting the full power out of the pack if there is a short, so less chance of your battery exploding on your table or in your hand or however you're doing it. So that's always a plus. No fires. So, and now comes a moment of truth. Plug that into our powertrain. You can see the bulb up here, and here we go. Here goes nothing. See if we let the magic smoke out. So I'm assuming, since that's beeping like that, and there was no smoke, that the ESC sees no control signals from a receiver or a radio, that's one of the safety features. I'm not quite sure with these new ones, but at least this tells me I can power this up without going poof. I'd have to look up the beep codes, which I may do before I proceed anyway. But anyway, we safely powered up the powertrain without it going poof on us, and that lets me get to the point where I can edit the third of this series.